This lesson is for GRE 301. Today we're going to be working with the coordinate plane. Your focus skill for today is to be able to locate points in the coordinate plane. Now, as a review skill, we have to make sure that you can actually locate points on a number line before you can actually locate points in the coordinate plane. So we're going to start here with some basic review. I want to plot these points on the number line provided. We're going to use the letter names when we plot them. So make sure that you're not just drawing a dot or a point. You need to actually label that point. Now I'm just going to pick a few of these to plot, and then you guys can try the rest on your own. I'm going to do B, G, and H. Okay, so for B, before I try to plot this, I need to make sure I evaluate 3 squared. So B is supposed to equal 3 squared. Well, 3 squared is 9. So when I evaluate that, now it's really easy to plot. I go to 9, put a point here, and make sure you're labeling that with a B. Okay, for G, 19/4. Now that's something it's a fraction, and it might be hard for you to evaluate that, but if you just stick it right in your calculator, you're going to get a decimal there. So 19/4, excuse me, so 19/4 is equal to 4.75. So I'm going to, when I plot this, I'm going to put it more than halfway between 4 and 5. I'm going to put it about halfway between the halfway between 4 and 5. So there's my point G. Okay, and then finally we have H, which is defined as the square root of 36. Now, if that's not something you can do in your head, you can use your calculator, find the square root key. The square root of 36 is 6, so H is right here on the 6. So I'd like you guys to try the rest of those, and then we're going to continue on now to our focus and isolation skill. So in number 2, we're asked to write the letter that represents the quantity on the number line. So here we're given a value. 2.2 is our first example, and we want to come to the number line here to figure out which of these points represents the value 2.2. Now 2.2, that's the same as 2 and 2/10. This is the tenths place, right? That's the decimal spot that represents the tenths place. So I'm looking for 2 and 2/10. Now when I come over to the diagram here, I know that it should be to the right of 2 because it's obviously bigger than 2. But the whole fact that it's 2/10 here, I need to make sure that I understand the scale in this diagram. Now between 2 and 3, there are 10 hash marks, okay, which means that each of these hash marks represents 1/10, okay? So if I want to go 2/10, there's 1/10, then there's 2/10, I'm at B. So 2.2 here is represented with the letter B. Now the second point that I'm trying to find, 2 and 6/10, this is written as a fraction, but that's the same as the decimal 2.6. So if it helps you to write it as a decimal, go ahead and do that. So like when you do this one on your own, make sure you put that in your calculator to figure out what the decimal is. So we have 2.6. Now in this case, again, I'm going 6/10, so I went 1, 2, 3, 4, 5, 6. So there's point F that represents 2 and 6/10. All right, at this point, I think you guys can do the rest of those ones on your own here, and we'll move on now to problem 3. So problem 3 is going to be an introduction into the coordinate plane. So I want you to make sure you're labeling your diagram correctly here. The first question says, label the x and the y axis. Now the x-axis is the horizontal line here. So this one here, and I'm drawing it in blue, is the x-axis in the coordinate plane. So this is called a coordinate plane. Okay. So we're going to be plotting points here in just a second. Now we want to label the y-axis as well. So in red here, this is the y-axis. To remember, which one is the x and which one's the y-axis, I like to think y to the sky. Okay, because the y goes up and down to the sky. Now the second part says label the origin. The origin is the set of points 0, 0. So here's our origin, 0, 0. Label the quadrants. Now this one is harder to remember, and I remember I always got confused when I had to do the quadrants until someone showed me a really easy trick. When you label your quadrants, they go in a C motion. Okay, so if you go around the quadrants here in a C direction, this is quadrant 1, and we use Roman numerals. This is quadrant 2, this is quadrant 3, and this is quadrant 4. If you're not comfortable with the Roman numerals here, you can always write 1, 2, 3, 4. That's fine. So it goes in a C. It starts up here, quadrant 1, then goes to quadrant 2, then quadrant 3, then quadrant 4. So I think that's a really easy mnemonic for you to remember the quadrants and the order of the quadrants. All right, so please make sure you went through and you labeled all the parts in the diagram. Now we're going to go ahead though. We're going to do part D here, which says plot and label the following points. Now make sure you actually label them with the letters here, like A, B, C, and D. You can't just draw a point because we need to be able to differentiate between the points. All right, so the point A is 3, -4. Now the first number is the x value and the second number listed is the y value. It goes in alphabetical order, so x comes first and then y. Now when you try to plot the point, you're always going to start at the origin. So if I start here, this tells me the direction that I'm going to be moving. The 3 is positive, so that means I'm traveling to the right 3 units. Okay, so I go to the right 3 units, which puts me right there. And then this second number, the y, tells me to go either up or down. Now because this is negative, I'm going down, this time 4 units. So if I go down 4 units, that places me right here. So that's where the coordinate of point A is going to be graphed. So I know that a lot of this is review for you guys, but some people still mess up plotting, and it's really important that we master this skill. Now for B, I'm going to plot the point -2, -6. So I start at the origin. I'm going to go left 2 and down 6 units. So there's point B. Okay. Point C is 0, -3. So I'm going to stay at the origin. I'm not going to move left or right, but I'm going to move down 3. So this is where point C is. And finally we have point D, which is -9, 7. So I'm going to go to the left from the origin, 9 units. Places me about right here. And then I'm going to go up 7 units. Okay, so up 7 units places me here. So there's point D. Now real quickly, let's just talk about where those points lie. So if we look at point A here lies in quadrant 4. So I'm going to write that as either Q4, or I can write that as Q and then the Roman numeral 4. Okay. Point B lies in quadrant 3. Okay. Point C doesn't lie on a quadrant at all. It actually lies on the y-axis. So we're going to list that one as being on the y-axis. And then point D is in quadrant 2. Quadrant 2 here. Okay. So we'll list it like that. Now, I just want to take a look at each of the coordinates and kind of look at the signs of the coordinates. Now, when you're in quadrant 1, both signs for your x and your y values will be positive and positive. Okay, both signs are going to be positive. But when you're in quadrant 2, like this point was here, the x value will always be negative and your y value will always be positive. Okay? When you're in quadrant 3, like B is, your x and your y's are both going to be negative. So we have negative values for our x and our y. And then finally for quadrant 4, here's a point in quadrant 4. Notice how your x value is positive and your y value is negative. Quadrant 4 will always have a positive x value and a negative y value. Alright, so there's the coordinate plane. Now I want you guys to try the following problems on your own. Okay, we're going to pick up next with our focus and context questions. These are our level 3 questions. Now number 6 says a spider is placed on the number line at 2. It moves to the right 6 places, then it turns around and moves 3 spaces to the left. Where does the spider end up? Now I've seen people do this visually, so they draw themselves a little number line. Because we're starting on just a normal number line. It doesn't say coordinate plane. This one says number line, so that's just a regular horizontal line. We're starting at 2. Okay, he moves 6 to the right. So if you move 6 to the right, you're going to be at the point 8. If he turns around though and he moves 3 spaces to the left, now he's going to be in between 2 and 8, and he's going to be at the point 5. 3 spaces to the left of 8 would give me the point 5. So the spider ends up at 5 on the number line. Now if you didn't want to use a diagram, you can do this with just numbers here. So a spider is placed at the number line at 2. Now he moves to the right 6 places. Well, that's like adding 6, okay, to the number. He turns around though and he moves 3 spaces to the left. So now we have to take away 3. So we have 2 plus 6 minus 3, which gives me 5. So I get the exact same answer if I do it visually with a diagram or if I just do it mathematically. Now for number 7, we're no longer dealing with a number line. This time we're dealing with the coordinate plane because we have coordinates here, -4, 10. So we have a point, -4, 10, which is moved 3 places down and 2 places to the right. We're supposed to find the new coordinates of this point. So I think here it's a little bit easier to just do this mathematically. We have the point -4, 10. Remember, the x value is the value that moves something left or right. The y value tells you how to move something up and down. So in this case, where it tells you that he moves 3 places down, that means we're going to take the y value and we're going to subtract 3 from that amount. So we take 10 and we subtract 3. Now the other part says that you are moving 2 places to the right. So this time, right is a positive direction, so I'm going to add 2 to this value. So I end up with -2, +7. -4 plus 2 is -2. 10 plus a -3 is 7. So there's the coordinate. Now part 8 says Gabe answered -7, 12 on the problem above. What do you think he did wrong? Now this is a pretty common error that we see. Okay, so that's why we're addressing it here in the lesson. Now Gabe, when he answered the question, he just looked at the 3 places down and he just attached that to the x since it was the first direction listed. But remember, down is the effect on the y value, not on the x value. So you don't want to subtract 3. So what he did is he subtracted 3 from 4 to get -7. And then when he wanted to move the 10, he added 2 to 10 to get 12 because he saw 2 places to the right and he did that on the y value instead of doing it on the x. So it's very common to do that. Okay. So Gabe added the wrong value to the x and y coordinate. So he switched what he should have been doing to the x and the y coordinate. All right, our last context question says Brett started at the point 3, -5, and he moved 2 units down and 5 units left. What point will Brett be located after moving? So we're going to take the point 3, -5, and mathematically we're going to adjust this point. So it says that he moved 2 units down. Remember, moving down is in the y direction. So we're going to move down 2 units, which means we're going to subtract a 2 from the -5. Then it says he moved 5 units left. Remember, for the moving left, that affects the x. So moving left means we're subtracting 5 from the x value. So if I do that, I have 3 minus 5, which gives me -2, and -5 minus 2, which gives me -7. So Brett is located after moving at the point -2, -7. All right, I would like you guys now to try the you try problems, and we're going to move on together to the extension skills. So go ahead and pause the video, try the you tries, and then we'll come back together to do the extension skills. All right, let's try our level 4 extension skill. So it says Isabel, Christian, and Alex are standing in a straight line in respective order. Now that terminology here, in respective order, just means that when you try to place Isabel, Christian, and Alex, you're going to go in order that they were given. So Isabel would be first, then Christian, and then Alex. So I'm going to draw a little segment here. And I'm going to have Isabel first, then I'll have Christian, and then I'll have Alex. Now, it's just a diagram, it's just a sketch, so it doesn't have to actually be accurate, but it is going to help me visualize the problem. Then it says Isabel and Christian are 5 yards apart. So Isabel and Christian here, the distance here is 5. And then it says that Isabel and Alex are 17 yards apart. So this time, it's going to be this segment that I would label 17. So Isabel to Alex is 17 yards. Now, we want to know how far apart are Christian and Alex. Well, that's pretty easy because we've drawn a diagram to show. We've done this skill before where we take the 17 and we subtract 5, so we know that those are 12 yards apart. So Christian and Alex are 12 yards apart. All right, it says Christian hurt his shoulder last month and knows the farthest he can throw a football is 32 feet. If he tries to throw a football to Alex from where he is standing, will he make it? Explain and show your work. Now, clearly, we just found that the distance between Christian and Alex was only 12 feet. So if Christian wants to throw a football to Alex, he will make it because it's not as much as 32 feet. So yes, he makes it. And for my explanation, I'm just going to show the distance between Christian and Alex. All right, now 14 is a little bit trickier. 14 says a driver was in Chicago and he parked his car at point XY. So now we don't have the location of where he's at. It's just in general XY. If the driver walked 2 units west and 10 units south and ended up at the point 60, what was the coordinate where his car was originally parked? So this question is tricky because we have to figure out what that XY original coordinate was. Now I'm going to start with that XY, and I know that the driver walked 2 units west. Now walking west, if this is north, east, south, and west, means he's going left 2 units. So if I go left 2 units, remember that's subtracting 2 from the x value. Okay, so I'm going to subtract 2 from that x value. Then it also says he walked 10 units south. So south means he's going down 10 units. So again, I'm going to subtract 10 from the y. Now he ends up at the point 6, 0. Okay, so this is where an equation actually is going to help us, because I have values that relate x, the original position, and the end position. If I take x and I subtract 2, I should end up at 6. So if I solve for x here, I have 8. So his original x position was 8. And then to solve for y, we're going to set up a very similar equation. Y minus 10 should give me 0. So that means that y would equal 10. So his original parked car was at the point 8, 10. So again, it's pretty tricky, but I think if you set up some equations, it'll be pretty easy for you. All right, the last problem here is number 15. It says a worm is at the origin and is crawling along the y-axis of a coordinate grid. Every day, the worm crawls up 3 places, but at night, he slips back down 2 places. How many days does it take the worm to get to 5 on the y-axis? So let's see, he's going up 3 units, but then he comes back down 2 units. So overall, his distance every night is only 1 unit up. Okay, so if he's only making it 1 unit up every single day, then it's going to take him at least 5 days to get to 5 on the y-axis. So it's going to take him 5 days to get to 5 on the y-axis. I just love worms. I think they're cute. All right, that is the end of the lesson. I would like you guys to try the next problems on your own, and you're going to check that in with the key, and then you can get started on your skill sheets. Nice job. Get to work.